Dear student, today we start with our unit number 5, inter-process communication. Under this unit, we will start with very important concept, that is a priority inversion. What is that priority inversion problem and how to solve this problem? Okay. Then, before starting the priority inversion, we will study some priority scheduling algorithms, or what are the different scheduling algorithms in real-time operating system. The first scheduling algorithm is clock driven. Second one is event driven, and third one is a priority based scheduling algorithms. Clock driven scheduling algorithm means depending upon the clock or depending upon the time given to each process, that process is get execute. Means if there is any person and we call that person at particular time, means we call that person at 10, then that person comes at 10 only, and that person is start their execution or start their communication. Okay, means the time is given for each and every process, and depending upon that time, that process is get executed. Means for example, P1 time is given as a 10 o'clock, then that process is start their execution at 10. Okay, then event driven means for example, event is generated or interrupt is generated to execute any particular process. Means for example, there is one boss and there is one employee. Boss asks to particular employee that you do this task. Means that event is generated, interrupt is generated by that boss to execute that particular process. Means depending upon the interrupt generation or event generation, the process is get executed. And the last one is a priority scheduling, and very much popular and most important scheduling algorithms are priority based algorithm. And 99% of embedded systems are using this type of algorithms for the scheduling. Then what are the different priority scheduling algorithm? The first one is a static scheduling algorithm and dynamic scheduling algorithm. Under that static, there are two main algorithms, that is a rate monotonic scheduling algorithm and deadline monotonic scheduling algorithm. And in dynamic, there are also two important algorithms, are earliest deadline first algorithm and least slack time first algorithm. Okay, today we will study what are the different problems of these priority scheduling algorithms. And one of the important problem or important drawback of these algorithms is priority inversion. Now what is mean by priority inversion? Why this type of problem is occurred? This type of problem is occurred due to only resource sharing. Different resources are shared by different real-time tasks, and due to which only this type of problem is occurred. Okay, then what is mean by this priority inversion? Let us consider there are two processes, T1 and T2. T1 and T2. T2 have highest priority than process T1. Okay, T1 and T2 are the two processes, but T2 have highest priority than T1. Let us consider T1 process comes in the ready queue, it start their execution. After some time, the another process comes, that is a T2. Both the processes are at ready queue, but the T1 is under running and T2 comes now only, but T2 have the highest priority than T1. Therefore, CPU is preempted from the process T1 and the processor is given to the T2, and T2 continue their execution until it completes their task. And after completion of their task, the CPU is given back to the lowest priority task, that is a T1. And T1 continue their execution and complete their execution, and in this way the processes are get executed. That is, T2 have the highest priority, therefore the processor is preempted from the process T1 and given to the T2. This type of behavior is a normal behavior that highest priority get executed first. But in some situations, the lowest priority processes executed first if there is a already present highest priority task. That is, the processor is preempted. The processor is preempted from highest priority task and given to lowest priority task. Such type of behavior of system is called as a priority inversion. That is, lowest priority task execute first and after that highest priority task get executed. Means it is a inverse of the normal behavior. Inverse of normal behavior. Therefore, this type of condition or this type of situation is called as a priority inversion. That is, priority inversion means if there is a highest priority task and lowest priority task both are present, but the lowest priority task is executed first than highest priority task. That type of situation is called as a priority inversion. Let us consider there are three processes, T1, T2 and T3. T3 have highest priority than T2 and T2 have highest priority than T1. Means out of these three, T3 have the highest priority and T2 have the higher priority than T1, and T1 is the lowest priority task. Highest priority task. Let us consider T1 process comes in the ready queue first and there is no other process comes, that is T2 and T3 are not comes yet. Therefore T1 start their execution and after some time the T1 acquire one resource, that is R1 is one resource present and R1 is acquired by the process T1 and T1 continue their execution. But after some time the T3 process comes and T3 have the highest priority than T1. Therefore processor is given to the T3 and T3 start their execution, and T3 is also require the resource R1, but that R1 is already acquired by the T1. Therefore T3 require that resource R1 is not available, that is busy with the T1. Therefore T3 is under the waiting state because T3 continued their execution after acquiring the R1, but R1 is already present with the T1. Now before T3 required that resource, the T2 process is already come in the ready queue, but the CPU is not given to the T2 because T3 is under the execution. But when the T3 is in the waiting state, T2 start their execution. That is, highest priority task is get preempted and lowest priority task, that is T2 have the lowest priority and that priority start their execution. Why T2 start their execution? Because T3 is in the waiting state. And T3 is in waiting state. Why it is in waiting state? Because it acquired the resource R1 and that R1 resource is already acquired by the T1. T1 when T3 get that resource R1 when T1 release that resource R1, but T1 is also in the waiting state. Therefore T1 cannot release that R1, and therefore R1 is not released by the T1, therefore T3 is not get that resource R1. Therefore T2 start their execution because T2 have the highest priority than T1. Therefore T2 start their execution, and after completion of the T2 task, the CPU is given to the next priority task, that is a T1, and then T1 start their execution, and after completion of the T1 task, T1 releases R1, and after releasing that R1 is acquired by the T3, and T3 start their execution, and in this way T3 complete their execution. In this situation, or in this case, what happens? T3 have the highest priority, but T3 waits until the completion of the lowest priority task, that is a T1 and T2. And this type of condition, this type of situation, we will call as a priority inversion. That is, the highest priority task is waiting until the completion of the lowest priority task due to the resource sharing only. Due to the R1 is shared by the T1, and T3 is also required that R1, but R1 is not released by the T1 until T1 complete their execution. When T1 releases R1, then only T3 get that R1, and then it start their execution. Therefore in between this, T2 get the chance to execute, because T1 have the lowest priority than T2. Therefore T2 definitely start their execution when T3 is in block state. Therefore this type of situation, this type of case is called as a priority inversion. Okay, in the next lecture we will study how to solve such type of problem. Thank you.